Hi all, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is Rohan's love for matrix. Let's read the question first. Here our question said, Rohan has a special love for the matrix, especially for the first element of the matrix. Being good at mathematics, he also loved to solve the different problems on the matrix. So one day, he started to multiply the matrix with the original matrix. The element of the original matrix here we have given 1 1 1 0, where a 0 0 position we have 1, a 0 1 we have 1, and a 10 we have 1, and a 11 we have 0. Given the power of the matrix n, we have to calculate a raised to power n, and we have to return the position of it in the matrix. Which position? A position 1 0, and we have to take the modulo of it, and we have to return that element, that number at that position, right? So in the first example, we are given n equal to 3. Here the output is 2, right? So let's understand this question. This is the matrix, which is the original matrix we are given, right? Where in this position it's a matrix name A, right? So A of 0 0 we have one value here, right? And A10 we have 1, A10 we have 1, right? And A11 position the value we have 0, right? Please don't compare this. Okay, so in the position of this we have 1 here, right? And in this position we have 1 here, in this position we have 1 here. Okay, so in this position we have 0 here. Okay, now we have to calculate a ki power n, where n we are given here is 3. Okay, so it means a ki power 3, simple, right? Now we have to multiply it 3 times. Which matrix? A matrix. So it should look like this: a into a, right? So let's first multiply this. Original matrix we have a is 1 1 1 0. Okay, so let me write here a is 1 1 1 0. Okay, now for calculate a ki power 3, let's first calculate a ki power 2, right? Let me write here a ki power 2. Okay, let me write here. Let's calculate here. A ki power 2 is a into a, simple. So my a is 1 1 1 0, right? And my second a is also same. Okay, now we have to multiply this. So I hope you know how to multiply matrix into matrix. Simple. For this element, we have to multiply this two values with this. So 1 into 1 plus 1 into 1, which is 2. For this case, 1 into 1, 1 into 0, which is 1. 1 into 1 and 0 into 1, which is 1. And in this case also we have 1. It means that my a ki power 2 is 2 1 1 1, right? Now we have a ki power 2, so let's calculate a ki power 3. Let's calculate a ki power 3 now. Okay, so a ki power 3 is equal to a ki power 3 equal to a ki power 2 into a, right? So we have a ki power 2, we have a. So let's calculate this. 1 1 1. Okay, so here we have 2. Okay, rest we have 1. And a is 1 1 1 0. Okay, now let's multiply this. So this into this, which is 2 into 1, which is 2. 1 into 1 we have 3. In this case 2 into 1, 1 into 0, which is 2. In this case we have 2. In this case we have 1. So we calculate a ki power 3, which is 3 2 2 1, right? Now we want this value, which is a, this position we have to return, which is 2. So my output here is 2, right? If you see in the question, our output is 2. I want a ki power 3. First of all, we have to calculate a ki power 3. After calculating, we have to return the position number 1 0 in my matrix, which is 2, right? Now, let's calculate a ki power 4 also to understand the pattern of it. So, a ki power 4 is a ki power 3 into a, right? So, we have a ki power 3, which is 3 2 2 1, and a is 1 1 1 0. Let's multiply now. So, if you see here, 3 into 1, 2 into 1, which is 5, right? And in this case, we have 3 into 1, 2 into 0, which is 3. In this case, 2 into 1, 1 into 1, which is 3. So in this case, 2 into 1, 1 into 0, which is 2, right? So let me write here a ki power 4. So a ki power 4 is 5, 3, 3, 2. So we have to return this value, so which is 3. If you see here, when n equal to 4, our output is 3. So this is my output. Now it's time to analyze the pattern here, right? It's a very simple question if you visualize the pattern of this, right? What is this? It's a simple. Let me write here first. Always we have to return this value. Always. It depends upon your value of n, right? So if my n equal to 1, my value is 1. N equal to 2, my value is 1. When n equal to 3, my value is 2. When n equal to 4, my value is 3. What is it? For example, let me write here. When n equal to 0, let's suppose it's not given. Let's suppose it's 0. So we have 0, we have 1, we have 1, we have 2, we have 3. What's the pattern? It's a Fibonacci series, right? So if you calculate n equal to 5, we have just addition of the previous values, which is 5. N equal to 6, just add the previous value to previous value, which is 8, right? It's a Fibonacci, right? Hope you understand the intuition. Let's code this now. We have to just write the code of Fibonacci here, right? Okay, so if my n equal to 1, because here the constraint said n is greater than or equal to 1, so no need to write n equal to 0 in this case. If n equal to 1, we have to return 1 here. Okay, and let's suppose a equal to 0, okay, and b equal to 1, and c is, we have to calculate using for loop. Okay, so the simple code of Fibonacci here, c equal to a plus b, as in the question said, we have to take the modulo. So first let's write the modulo here. Okay, so we have to take the modulo here, and we have to update my a and b. A equal to b and b equal to c. At the end of it, we just return my c. Okay, so let's compile and check. Yeah, the compilation is good. Let's submit. Yeah, as you see, all the test cases are passed, right? So what's the time complexity of this? Simple. We are just traversing my loop up to n, right? So what's my complexity here? My time complexity is big of n, right? And here we are not using any extra space. So my space here is constant, which is big of 1, right? Hope you understand the solution and intuition. Thank you so much.